Hey everyone, today I'm going to be walking through a little bit more of an advanced derivative. Now, at first look at this one, it looks pretty complicated, and there's a couple different mixed rules that are hidden right inside of this. If you zoom in a little bit here, so you can see here we have what's called a product rule right off the bat. And a product rule, if you're not familiar, is when you're multiplying your deriving variables together. Okay, so you can see here our deriving variable is x, and we are multiplying x squared by cosine of 4x. And you can't multiply the two of those together and distribute them out. So this is when we get the product rule. Now, the product rule is defined by the following. F prime of x equals f prime x times g of x plus g prime x times f of x. And when I was in high school, my teacher called this fig gif. You can see it kind of looks like fig gif here. It looks like an eye almost in the middle. Fig gif, and that's your product rule. That's a good way to memorize everything for this. So let's first figure out what our f and g terms are. This is me from the future. We're actually going to call this h prime of x. We'll see later. Now I'm going to separate the f and g terms by the left and right for this example. So the left side is going to be f of x, and the right side is going to be g of x. And let's rewrite this below. So f of x equals x squared, and g of x equals cosine of 4x. Now on the left side here, you can see that this is just a product rule. So when we do the product rule, we're going to have to take the derivative of each function. So we're going to have to find f of x, and we're going to have to find g of x. Now the derivative of f of x is very straightforward. This is just a power rule. So now the power rule is just bringing your n term down and doing n minus 1 in your exponent here. So let's do that. Let's bring the 2 in front because here n equals 2. So we have 2x times 2 minus 1, and that means that f of x is just going to equal 2x. So over here on the right side, we're going to have to derive g of x. And g of x is a bit more complicated than f of x is here because we have what's called a chain rule. And a chain rule, especially for trigonometric functions, is when you have a trigonometric function with a deriving term on the inside. In this case, our deriving term is x, and that is within the parentheses of this function. The formula for this is we're going to eventually take the derivative of the outside times the inside, which in this case is 4 of x, times the derivative of the inside, and that's going to show up here. Let me show you what I mean. We're going to call the inside u of x, and then we can rewrite this over here because we are going to have to take the derivative of the inside. So u of x equals 4x, and then u prime of x equals 4. All right, we know this is just a simple power rule, and the x will drop off. So the formula calls to take the derivative of the outside here. So if we look at our table over here, we can see that we have our original trigonometric function and the derivative of that function. And in this case, we're looking at cosine x. And the derivative of cosine x is negative sine of x. This is a great table to memorize because it's going to really help you with taking your derivatives and eventually your integrals. So I'd strongly recommend memorizing this table, especially these here on the left. The right side, maybe not as much, you won't see those, but this left side is very important. So let's go back over here and take the derivative of the outside of the function. So the derivative of cosine, as we can see here, is negative sine x. So let's put negative sine here, times the inside, which is u of x, times the derivative of the outside, which is u prime of x. And you don't have to do these substitutions. I just did it like this to make it a little bit easier, but we can see that once we plug these back in, u of x equals 4x, and u prime of x equals 4. and then bring the 4 to the front just to make it a little bit neater. We have negative 4 sine of 4x. And eventually when you get good at these, you'll be able to just say cosine 4x, and then the derivative is negative 4 sine 4x. And then, for example, you would have, let's say, sine of x squared. The derivative of sine of x squared is really, if you look at the table up here, cosine of x squared times 2x. Since 2x is the derivative of x squared, we're always multiplying by the derivative of this inside term here. So we always bring this out and take the derivative and multiply the function by that. And you can see that's also what we did over here. So we know that g prime, let me put this in black, we know that g prime of x equals negative 4 sine of 4x. And over here, f of x equals 2x. Great. Oh, this is f prime x. There we go. So let's go back to our original function for the product rule. All right, so let's rewrite this down here. H prime of x, and now we can start substituting in our functions. So let me just highlight everything. We have f prime of x, g prime of x, g of x, and f of x here. These are the 4 most important terms, and you're always going to want to separate it like this, especially when starting out this rule. So now let's substitute everything in. We have f prime of x is 2x times g of x, which is cosine of 4x. All right, there's our first 2 terms here. F prime x times g of x plus, let's substitute for g prime x, negative 4 sine of 4x. And we're going to multiply that by f of x times x squared. Great. So this is g prime x times f of x. All right. So now we can distribute this minus a little bit and make things look a little bit neater. So this is going to be 2x cosine 4x minus 4x squared sine 4x. And I'm just moving these terms around a little bit to make them a little bit neater. And we can actually pull a 2x out of this term. So let's do 2x cosine 4x minus 2x sine 4x. And let's just put some brackets around these to make it look a little bit neater. And that is your derivative. So let me rewrite this a little bit. This is equal to d over dx of x squared cosine 4x. All right, and let's take a look at this problem once more. The biggest thing here is really when you first open up the equation, you want to see how many rules we're starting with. Recognize the product rule to start. This is the most important one because you can split it, and then you can look at each equation separately as we did down here when we separated them on the left and right side. If you have any questions, please feel free to comment below. I will get back to them as quick as possible.